So this is 2C worksheet number 7. We've got a sports car stopping. It says that the skid marks are 290 meters long. 290.0 meters. The skid marks are the marks that you're going to see from the point when the brakes begin to be applied until the point when velocity comes to 0. Police report cites the speed. What we want to know, so we've got delta x. We're given delta t. We know VF, and what we're looking for is VI. Was that a light bulb for anybody? Does that fix it? Or not yet? Nope? Okay. So when I look at the problem and I list the variables, and then I look back at the note card, what I'm looking for is an equation that ties together the 4 things that I need. You know, the 3 things I have and the 1 thing I'm missing. I will say this. The note card that you see here in this gold box, and this is just a custom background that I made for Doceri, that is literally all I have on my note card. I don't have every derivation of those that you can use, and here's why. Because they can all only be used under very particular circumstances. Oh, well, this one only works if VI is 0. Well, this one only works if delta x is 0. Oh, well, this one, and it gets more specific as we get into chapter 3. So for me, and some students have reported the same thing, if you clutter that up too much and you don't just keep going back to the original basics and working from there, you tend to sometimes trip over your own feet because there's actually too much to sort through. So I like the keep it simple, stupid philosophy because goodness knows I tend to get stupid. Does that fix it? Now?
It's just
well, and let's talk about this. The problems are written with extraneous information. And I do the same thing to you. I will write in all kinds of bizarre stuff. And you know, I learned that from the textbook authors. Reason being, when you're solving, I mean, physics is actual stuff out in the world. And when you're looking at actual stuff out in the world, there's a whole lot of information, and you have to decide which pieces matter and which pieces go into your calculation and which pieces don't. So they kind of do that on purpose. Okay, so we're good on number 7. This is the polar bear is an excellent swimmer, spends a large part of its time in the water. Polar bear wants to swim from an ice floe to a particular point on shore, dives into the water, begins swimming with a speed of 2.6 meters per second. By the time the bear arrives at the shore, its speed is decreased to 2.2 meters per second. If the polar bear's swim takes 9 minutes and it has constant deceleration, I hate that they use that, what's the distance traveled by the bear? So we have VI, VF, delta t looking for x. And does this fix anything yet? Not yet? Okay, that's fine. So this is 9.00 minutes, 60 seconds in 1 minute. VI is 2.60 meters per second. VF is 2.20 meters per second. So again, we're looking at the four variables that we have: VI, VF, delta t, delta x. And that points us towards that equation. Does this fix anything yet? Any questions on 2D? Note that when I put the video into Doceri, that means I can see if you watched it or not. So you do need to log in on your own account to watch it, because I look at that and say like, oh, this person watched it, this person didn't. If I call you on the rug about like, hey, you didn't watch the video, and you in fact did, show me your Doceri account. Last year we did have 1 or 2 cases where it would register, it wouldn't register on my device, though it was really only 1 or 2, and then they changed the format and it seemed to work. But anyway, because I did have a few people who it didn't look like watched the video, so you don't want to like earbud split with somebody else, because I want to see that you watched the video. Any questions on the 2D problems? Yes, sir. In the book, this is book?
Yeah, we didn't have to worry.
Right, that's what I thought. Okay, let's look at the 2D book. This is 2D number 3. Car starts from rest, travels 5 seconds, uniform acceleration, what's the final velocity? So we're given VI, we're given acceleration and we are given time. We are being asked for VF. So VI is 0. Acceleration is negative 1.5 meters per second squared. And delta t is 5.0 seconds. Did this solve anything yet? All right, so when we look at VIA, delta t, VF, does this start to point us towards any of the golden equations that we've got so far? And so far we don't have that one. Hey, did you do that one and you've still got an issue? Good question. So they're giving us a negative acceleration. And we've talked a little bit about the whole negative positive acceleration, negative positive displacement. We're starting from rest. We know that if this object is accelerating, its velocity, the absolute value of its velocity has to be increasing. It's got to be moving away from 0 on that y-axis. So the final velocity then is going to be negative because we're going from 0 to some greater than 0 magnitude velocity. The only sensible, logical explanation is that, yeah, if we picture this as, a car on a number line, it's moving in a negative direction. So, yeah, but the magnitude of its velocity is increasing. The thing's obviously speeding up, but yes, it's getting a large negative velocity. Other questions? Okay, with that, the first question to ask yourself in any physics problem is, no, seriously, did you list your variables? That's the key thing, because once you list your variables, you can look at the golden equations and figure out which one of them it makes sense to use. Okay, that's it. Work.